relationship between marital status and happiness. The data show the marital status and happiness of individuals who participated in the general social survey. Fine. Compute the expected counts. So number one, expected counts. What is this? Well, we're going to conduct a test, and the expected count is and the expected counts have to be greater than or equal to 5 at all times. This is the condition of the test. No more than 20%, so all expected frequency are greater than or equal to 1, but we no more than 20% of the expected frequencies are less than 5. Okay, so we expect the number to be higher than 5. Okay, so what are we trying to do? So what is the expected count? That will be a matrix that we will obtain with a calculator. What is a matrix, first of all? I don't know if you took college algebra or not before this class, but the matrix is an array of numbers. Why do I need the matrix? I need a matrix to conduct this test. The test called chi-square requires a matrix. Why? Why haven't we used the matrix before? Because we've never looked at a table before. In our test of hypothesis, we never had a table before. But this specific situation is when we are trying to see if the column variable and the row variable are dependent or independent, we have to use a table. And the matrix is an array of numbers or a table of numbers. Where will I find in the graphing calculator a table of numbers? And I will enter this table in a minute. So here is the matrix that we will enter, and we will denote it by A. Normally, matrices are denoted by uppercase letters, not necessarily. We can also use lowercase letters, but normally and even the calculator uses uppercase letters. Okay, so what is the matrix that I'm going to enter? I'm going to enter the matrix 600, 63, 112, 144, 720, 142, 355, 459, 93, 51, 119, and 127. Okay, where do I enter this matrix? So see, the matrix is in my calculator in blue, so I have to activate it with the second key. Anything that is in the background, it needs to be activated with a second key. So we go to second and matrix, and we will go to edit. We're going to edit a matrix. What is this matrix? It has 3 rows and it has 4 columns. So when I click on edit, I have to make sure that I enter 3 and 4, meaning 3 by 4 means 3 rows and 4 columns. And then the template pops up. It's waiting for me to enter the information. I will enter the information on rows. 600, enter. 63, enter. 112, enter. 144. Every time I have to click on enter. 720, 142, 355, 459, 93, 51, 119, and 127. Make sure you have all this information in there. Let me know if you entered it already.
I entered it.
Very good. Here's our next step. Get out of there with second and quit. Let's go to stat. Of course, across to tests. And let's look for the chi-square. There are two different tests for chi-square. We're looking for the regular chi-square test, not the GOF, that stands for goodness of fit test. We're looking for the regular chi-square test, which in my calculator is item C. And press enter. We entered the matrix A, which is the matrix of observed data. We entered the observed data. Now, what is already what you see here, it's called expected. So the calculator will conduct the test and will create what it's called the expected values. So let's conduct the test and we'll see in a moment. Let's calculate. Is everyone okay with this? Should I press calculate?
Yes.
Okay. So we determined, the calculator determined that the chi-square, which is the chi-square statistics, right? We had Z statistic, we had T statistic. Well, we are conducting a chi-square test. So this must be the chi-square statistic, which is 224.11, which is less important, but look at the p-value, degrees of freedom for the chi-square test. Degrees of freedom for the chi-square test is determined by how many rows we had, 2 minus 1. How many columns we had, 4 minus 1. So 2 minus 1, it's 2 minus 1, C minus 1, degrees of freedom. Where, right? So 1 multiplied by 3. No, sorry. So 3 rows, 4 columns. 3 minus 1 is 2, 4 minus 1 is 3. That's why the calculator gives us 6 degrees of freedom. So that's why it's 6. And the p-value, look at the p-value. It's 10 to negative 45. That's almost 0. So it's 1.38 times 10 to negative 45. That's absolutely 0. So what do we conclude then? What do we conclude? And you can say, but where is alpha? How can you make a decision with any alpha? Without alpha, we can't, no matter what alpha. No matter how small I choose alpha to be, what do I have to do in this situation? What do you think?
You centered the paper a little bit.
Is this better?
If it could come down and to the left a little bit. Thank you.
Sorry about that.
That's fine.
Okay, we didn't copy the expected values, but can anyone give us the result, the conclusion? What is the conclusion? Anyone? We reject independence or we fail to reject independence? Are the two variables, categories related? Happiness and marital status? Is there an association or they are completely independent? One does not influence the other. Anyone? And then we'll put the matrix of expected values to check. What do you think? Anyone?
I'd say there's a correlation.
So there is an association. They are not
Yes.
independent. Very good. So we have to reject H naught of independence. There is sufficient evidence coming from the sample to reject the independence. There is a relationship. They are associated. Okay, since we already asked the calculator to determine the expected values, they are already saved in matrix B. So let's go back to second and matrix. And let's go to edit and scroll down to 2, if that's what you have, or I don't know if you entered it in A and B. And here are the expected values. Okay, 435.02. Of course, the observed values cannot be 0.2 or 0.3, right? But the expected values, the calculated ones, could be. So 793.36, 184.61, 78.815, 143.74, 33.447, 180.41, 329.02, 76.563, 224.75, and 409.88. As you see, all of them are above 5. 20% could be less than 5, but definitely more than 1, etc. But not. How does, what is the formula in case you want to use the formula for this? It's not a very friendly formula for the chi-square statistic. It's the sum of ratios, and this is squared, and this is the expected. So from I equals 1 through n, from EI, the observed minus the expected. I'm not going to ask you to determine that. It's not a friendly calculation. Of course not. So now let's try the same thing with StatCrunch. See how this works. I'm hoping that I can get in.
I was going to say, hopefully you're able to get them on.
Yes, if not, I think I can bring the other device into play. Because I never thought I would say that I like the Microsoft Surface. I never thought I would treasure it, but now because it's recording everything for me, I like it. Oh no. Okay, I'm going to stop sharing. And I'm going to bring this device